Good afternoon and welcome. My name is Carl Pearson. I'm the Associate Director at the Center for the Study of the Middle East at Indiana University. We're a Title VI Comprehensive National Resource Center funded by the U.S. Department of Education, and we'd like to thank our funders before we begin. If you would like to be added to the Sesame listserv, feel free to email me. You can see my email down here at the bottom of my box. I will change that to say Carl Pearson, but I'll leave my email there in it as well. Many thanks to our wonderful staff here at Sesame, Sayed Amir Asghari, Recep Erkman, Shems Al-Ubaidi, and Adria Hedinger for help in making today's presentation possible. And though it has now been said many times, it still bears repeating that we wish very much that we were meeting in person today. And we look forward to the time, hopefully in the near future, in which our speaker can join us and experience Hoosier hospitality here at IU. So with that, let me introduce today's speaker. One last thing before I do. In terms of, Professor Derr has agreed to answer questions following her talk. So if you have a question for her, please type it into the chat feature, and I will relay the questions at the end of the talk so that she can respond to your questions or comments. Sesame is proud to present Professor Jennifer Derr today. She is a professor in the Department of History at UC Santa Cruz and received her PhD from Stanford. Her work is at the intersection of Middle East studies, environmental and disease history, and the history of colonialism and capitalism. She's won numerous awards, including a National Science Foundation Career Award, History of Science at the Interface of Biomedical Environmental Concerns, and a fellowship at the Max Planck Institute for Wissenschaftsgeschichte. Her first book came out in 2019 from Stanford University Press and is entitled The Lived Nile: Environment, Disease, and Material Colonial Economy in Egypt. Today, her talk is entitled Ecologies of Disease on the Dammed River Nile, and we're very happy to welcome Professor Derr via Zoom to Indiana University.
Thank you so much, Carl. I'm going to begin by sharing my screen with everyone. So thank you so much to Carl and also to the Center for the Study of the Middle East at Indiana University for hosting me today, and also to all of you for taking time out of your busy schedules. So as Carl mentioned, my talk today derives from my recent book, The Lived Nile, which was published by Stanford University Press in 2019. And I'll show you a quick picture of the book. I'd like to begin today with an excerpt from a folk song that was sung by agricultural laborers in Egypt in the early years of the 20th century. Now, the song described the use of a handheld tool to irrigate crops. This tool, which is a tool known as the shadoof, consisted of a basket or a bucket that was attached to the end of a wooden crossbar and fitted with a counterbalancing weight, and then balanced on two vertical supports planted in the soil about a meter apart. So as you see in this photo. Now, what is perhaps not evident from the photo is that work on the shadoof was tremendously difficult and physically taxing. Men spent the length of the day in the sun, whipped by wind, and soaked by the water that fell as they repeatedly raised and lowered the instruments. Songs describing what it meant to use the instrument featured prominently the bodily toll that it exacted. And I'm going to read to you one of those songs. This morning I am weary. My entire body is sick. I am weary, ya awlad. Stiffened like a stick or as dry leather, I am weary, ya awlad. You unceasingly exhaust me. I fear you, O stock of the shadoof. I am weary, ya awlad. I tremble like a leaf looking at the stalk of the shadoof. I am weary, ya awlad. My hands are bruised on the wood of the stalk of the shadoof. My hands are injured. I call out for a doctor. He heals my hands and then says, pull the stalk of the shadoof. Give me a good doctor, a bit of respite. The world is quite bad because I cannot rest. I am weary, ya awlad. Now, beginning in the second decade of the 19th century, Egyptian agriculture underwent a transformation that dramatically reshaped agricultural labor regimes, including those involving the shadoof. In the approximate century that stretched from the 1860s, a colonial economy rooted in the production of cotton for export coalesced in Egypt. This colonial economy was defined by the prominence of cash crop agriculture, the stunting of industrial development, and the dominance of a landowning wealthy elite over large swaths of the countryside. During this period, many Egyptian peasants were forced into existences as sharecroppers or agricultural wage laborers. The formation of this colonial economy was first supported by the 19th century Ottoman Egyptian state and its wealthy agricultural landholders. It continued to develop, and in fact, its development accelerated in the decades of the British occupation and under the quasi-independent state that ruled the country during the interwar period. Now, Egypt's colonial economy was rooted in a set of environmental transformations. For millennia, Egyptian agriculture had corresponded with the rhythms of the annual Nile flood. When the inundation arrived each year, and it arrived in late July or early August, floodwaters were admitted into large basins that lined the Nile Delta and the Nile Valley, where they soaked and fertilized the soil. After these waters were evacuated, crops were then planted in basins. Egypt's primary agricultural bounty was in the form of crops like wheat, whose growing cycles paired with the temporality of the flood. Cotton, which needed watering in the parched days before the flood's arrival, was not among those crops. So before I move on, I just want to show you two quick images. So this is an image of what a basin would have looked like when it was full of a small amount of water. You can see this basin is planted with date palms. And here is an image of the kind of topography that replaced basin agriculture. So to support widespread cotton cultivation, the fundamental temporalities of Egyptian agriculture were altered. Networks of irrigation canals replaced basins. Barrages were built to augment the height of the river and help to channel water into canals. And in 1902, the first dam was completed on the Nile River. So this dam, which is named Khazen Aswan, or somewhat anachronistically, the Aswan Low Dam, stored water that was released in the late spring and early summer to irrigate cotton crops. And I want to show you a few images of this infrastructure. So this is an image of a kind of—
Jennifer.
Yes.
So I'm sorry to interrupt, but you've stopped sharing your screen.
Oh, no.
So could you?
Absolutely. Have I begun again?
Yes.
Excellent. So this is an image of a kind of, what a basin might have looked like when it was quite full. Oops. My slideshow, I'm having some difficulties here. Hold on just a moment. Have I stopped sharing again? Can you see my screen now?
Yes.
Okay, so that was an image of what a basin might have looked like when it was full. This is an image of the Delta Barrage, which sat at the apex of the Nile Delta and helped to funnel irrigation water into newly excavated canals. This is a postcard that depicted Khazen Aswan, or the Aswan Low Dam. Now, this web of infrastructure enabled the practice of perennial irrigation, which supported year-round agricultural production and the cultivation of summer crops that included cotton, whose growing cycles did not pair with that of the flood. By the second decade of the 20th century, a formation that I have called the perennial Nile River had spread throughout the northern Nile Delta and into central Egypt, and even extended into portions of Egypt's deep south. Within this geography, irrigation water was available year-round. Cash crops that included not only cotton, but also maize and sugarcane were widespread, and also the embodied experiences that constituted agricultural labor and rural life were transformed. So just to give you a sense of what that looked like, this is a map that shows very approximately what the perennial Nile River would have looked like. So where it says in the center of Egypt, the 1902 irrigation frontier, the perennial Nile River refers to those portions of the Nile River that lay to the north, and the kind of blue dots that are in southern Egypt that tended to grow sugarcane. So it is this last piece of the equation of the perennial Nile, which is that of the embodied experiences, that I'll focus on in my talk today. So in rural villages that depended on the Nile for their water, the canals that facilitated perennial irrigation also became centers of village life. Approaching the Nile could be treacherous, especially when the river ran high and fast during flood. And at the turn of the 19th century, when Egyptian villages lacked running water, canals became sites for a whole host of activities. Men labored in these waterways, women fetched water and washed clothes in them, and children frolicked in their waters when the temperature soared. And you know what? I want to actually step away from the screen sharing so you can see my face. Does that make sense? Oops.
So currently we can see your face.
You can.
Yes.
Great. Okay. Now, canals also served another function, and that was that in a landscape that was devoid of cover, they were also sites at which to urinate and defecate, especially for cultivators engaged in the act of irrigation. Human beings not only lived the ecologies of the perennial Nile through the daily rhythms of rural life, their labor was also central to the construction and the maintenance of this environment. So labor was a primary means of producing environmental relationality. And one facet of this relationality was the widespread prevalence of disease in the territories of the perennial Nile River. So my talk today will consist of two parts. In the first part of my talk, I'll describe the history surrounding a prominent set of diseases and how their significance was transformed beginning in the late 19th century. I'll then demonstrate how these diseases helped to shape the imaginaries and methods that undergirded the practice of medicine in Egypt, especially during the interwar period. Now, the introduction and spread of perennial irrigation throughout large swaths of Egypt was associated with a set of environmental changes. The practice of perennial agriculture meant that the Nile flood no longer soaked the soil. And this was because when the flood arrived, these soils were planted with summer crops like cotton. Deprived of the rinsing that had been performed by floodwaters, salts and minerals accumulated and left soils increasingly saline. The presence of year-round irrigation water also caused the subsoil water table to rise, and much of the earth in perennially irrigated regions became waterlogged. Cotton leached nutrients from the soil, and also the demand for artificial fertilizers increased. By the 1930s, Egyptian agriculture consumed a larger portion of artificial fertilizer per cultivated area of land than any other region in the world. Cotton fields also had their own unique ecologies, some of which included insects. So the Egyptian bollworm tunneled into cotton buds and fed on its bolls, and cotton worms also feasted on the plant. And both of those insects are featured prominently in literature from the late 19th and early 20th century because they devoured cotton crops. Now, the ecologies of the perennial Nile also carved the bodies of rural Egyptians. When the weather warmed, parasites proliferated in the waters that filled irrigation canals and drains, and also in the perpetually moist soils of canals and fields. Diets also changed among agricultural communities in regions with access to perennial irrigation, in some cases sickening these populations. In the territories that comprise the perennial Nile, the majority of the population suffered from a disease whose cause could be directly linked to the new agricultural landscape and the practices that structured material interactions between human beings and the environment. Now, among the diseases of perennially irrigated agriculture, schistosomiasis was the most prevalent. So known as Egypt as bilharzia or bilharzia, schistosomiasis results from infection with the parasites of the schistosoma genus, which infect human beings through the contact of their unbroken skin with fresh water that contains both the parasite and the species of freshwater snail that serves as the intermediate host for the parasite. In Egypt, two species of parasite can produce schistosomiasis. Schistosoma hematobium is passed through urine and usually infects the urinary tract, while Schistosoma mansoni exits the human body in feces and often targets the digestive system. In the late 19th century and the first half of the 20th, infection with Schistosoma hematobium was the most common cause of schistosomiasis in Egypt. Now, beginning in the late 19th century, infections with both species of the schistosoma parasites became more common and also more severe in regions with access to perennial irrigation. While epidemiological statistics charting the prevalence of schistosomiasis were not produced until the late 19th century, the available historical evidence conclusively demonstrates that the prevalence of infection and also the likelihood of reinfection soared with the introduction and extension of perennial irrigation. In the early 1930s, Rockefeller Foundation parasitologist James Allen Scott conducted the first nationwide survey of the prevalence of schistosomiasis in Egypt. What he found was that in the Nile Delta and the Nile Valley, where infection with Schistosoma hematobium was endemic, infection rates averaged 60% in regions with access to perennial irrigation. And in some towns of the Nile Delta, where perennial irrigation arrived first, the rate of infection exceeded 90%. Now, just to give you a point of comparison as to what the world looked like before the arrival of perennial irrigation, in areas of southern Egypt that did not have access to perennial irrigation and continued to practice basin agriculture, infection averages hovered somewhere around 5%. Now, in the more limited areas of the country in which the parasite Schistosoma mansoni was endemic, infection rates hovered around 60%, so resembling those of Schistosoma hematobium. Now, part of the reason for this was that irrigation canals and drains were ideal habitats for the tiny freshwater snails that serve as the parasite's intermediate hosts. These snails do not fare well in large bodies of rapidly moving water, such as the Nile River, but they thrive in sluggish water, like that in irrigation canals and drains. However, it was not only the prevalence of snails that was the cause of increased infection rates. New modes of environmental interaction also placed agricultural populations and cultivators in particular, in frequent and intimate contact with the water that filled irrigation canals and drains. Among adults, those who labored in agriculture, usually men, were vulnerable to infection with schistosoma parasites. And male cultivators who were engaged in the act of irrigation faced frequent infection and reinfection with the parasites that caused schistosomiasis, as they were often immersed in the water that filled canals and drains up to their knees or waist. And this was water that contained both populations of parasites and also freshwater snail. So on average, the percentage of women infected with schistosomiasis in areas with access to perennial irrigation was about 10 percentage points lower than that among men. And the prevalence of schistosomiasis among children was generally high. Now, the spread of perennial irrigation also encouraged the prevalence of hookworm disease to increase. Passed through infected excrement, the hookworm parasite infects human beings through direct contact with the skin, often entering the human body through the feet and less commonly through ingestion. On the banks of canals and in fields that rarely dried, an increase in the moisture level of the soil helped hookworm to thrive. Cultivators, their feet lodged in the mud of fields, and that from which irrigation canals were molded, were easily infected with hookworm larvae. Mud itself was so central to the perennially irrigated landscape that when British officials at the Egyptian Ministry of Public Works accounted for the labor necessary to clean canals, they did so in units of earth. And more often than not, this earth was dug out by laborers using their bare hands as tools. Now, whereas a direct relationship existed between the introduction of perennial irrigation and dramatically increased rates of schistosomiasis, that linking irrigation practice to the prevalence of hookworm infection was relatively more complex. Perennial irrigation was one of a complex array of factors encouraging infection. Climate and soil composition also played a role. The introduction of perennial irrigation in the Nile Delta and in Central Egypt, and the subsequent rise in the moisture level of the soil, caused the prevalence of infection in those regions to rise. By the early 20th century, severe hookworm infection was the most common medical condition, disqualifying potential recruits for the Egyptian army. And by 1934, James Allen Scott, so the same parasitologist who did the nationwide survey of schistosomiasis, Scott estimated that 5 of Egypt's 12 million inhabitants were infected with hookworm. So as with schistosomiasis, hookworm helped to gender the body of rural Egyptians during the late 19th and early 20th centuries. Rates of infection among children were generally high, and I can talk about why a little bit more in the question and answer. But among adults, men faced a greater risk. A study conducted in the summer of 1927 found that while large numbers of men and women were infected with hookworm, the proportion of men at all ages who were infected was consistently higher, peaking between the ages of 25 and 30 before declining gradually. Now, finally, as perennial irrigation spread, so did the cultivation of maize or of corn, which could be cultivated in Egypt in roughly the same season as cotton. In the late 19th and early 20th centuries, the surface area of agricultural land that was occupied by maize expanded dramatically as the crop replaced barley and wheat in rural diets. By 1902, maize covered approximately 1/5 of the cultivable land in the Nile Delta. Now, maize is an interesting crop historically because it is famously a staple of the impoverished. And in Egypt, this group included the peasants who labored over the crops of colonial economy. Corn was eaten green and roasted, it was dried, or more commonly, it was made into bread after it had been ground. However, while maize fed, it did so at a price. Those who relied too heavily on its consumption developed the disease pellagra, which is caused by a deficiency of tryptophan and ultimately a shortage of niacin in the body. So metabolically available niacin is central to the production of nucleic acids, which are the body's most important biomolecules. Niacin is also important to the release of energy from carbohydrates, fats, and proteins. So in short, those who suffered from pellagra were missing the basic elements necessary for healthy cellular function. Now, descriptions of the disease's ravages in Egypt are plentiful, although because it wasn't caused by a parasite, it was more difficult to measure than either hookworm or schistosomiasis. One study performed in 1902 in the province of Gharbeya in the Nile Delta revealed that among 315 Egyptian men, 36% exhibited the visible symptoms of pellagra. So usually those that had visible symptoms tended to have more severe cases of the disease. Now, in the territories that comprise the perennial Nile River, so in the Nile Delta and in central Egypt, symptoms of disease became so common that they came to constitute normative habitations of the body. It was very common for rural populations to suffer some combination of pellagra, hookworm, and schistosomiasis. And in the case of schistosomiasis, it was not uncommon for someone to be infected with both species of the parasite that caused the disease. Now, while each disease produces its own set of symptoms, to inhabit a rural body in the period of Egypt's colonial economy, and especially a laboring body, often included the symptoms of multiple diseases. So fever, fatigue, aching cough, diarrhea, abdominal pain, constipation, weight loss, and vomiting, all of these symptoms were commonplace. These experiences could be accompanied by blood in the urine, cancer of the bladder, high blood pressure through the liver, an enlarged spleen, the buildup of fluid in different parts of the body, swollen areas in the esophagus and digestive tract that could rupture and bleed, severe anemia, stunted growth, difficulty concentrating, impotence, a photosensitive rash, painful growths on the scrotum, vagina, and rectum, and disorders of the nervous system that caused memory loss, depression, and eventually dementia. So I think it's important to mention here that in looking at the historical records of these diseases, we see these records not only in biomedical institutions, but also in the psychiatric hospital that was built at Abbaseya. Now, these forms of embodiment were regionally specific to the environment that was associated with Egypt's colonial economy, that of the perennial Nile River. They were, in fact, so common that those laboring over agriculture understood some of these symptoms to constitute normative habitations of the body. So one of the most sort of well-known examples of this is that the blood in the urine that often accompanies schistosomiasis was understood among some rural populations as a form of male menstruation. And this made sense because boys usually began to perform irrigation labor in their teenage years. This labor not only increasing the likelihood of infection, but also the severity of the infection that they were likely to suffer. Now, while sparse, historical evidence also suggests that rural communities made note of the symptoms of the diseases of perennial irrigation, many of which were predictably seasonal. Disease was not imagined as a systemic phenomenon, but it was rather imagined through its individual symptoms. Egyptians referred to the rash of pellagra that usually bloomed in the spring as khashuf, for a roughness and a chafing of the skin. Rihakon, which was a reference to saffron, was the anemia that gave a visible yellow pallor to the skin with severe hookworm infection. Agricultural populations in the Nile Delta understood the blood and the urine in the ways that we just referenced, and also as a sign of fertility and the coming of age. The bu'una itch was an intense sensation that cultivators experienced when schistosoma parasites penetrated their skin during the morning hours of the Coptic month of bu'una, which roughly corresponds with the month of June. Now, one of the arguments that I make in my work is that the particular and overlapping experiences of disease created distinct experiences of agricultural temporality. So the production of the perennial Nile River produced new agricultural seasons and labor regimes that altered the way that time was marked in the countryside. So did the progression of disease inside the body mark a different scale of agricultural temporality. Now, as an example of this, I want to follow a hookworm infection through the body with you. So once inside the body, a hookworm larva begins a journey to the lungs 3 days in length. After its arrival, the organism breaks through the alveoli to travel to the trachea, where it is swallowed, passes through the esophagus, and enters the digestive system. It reaches the small intestine approximately 1 week after it first penetrates the skin. In the intestines, the organism matures sexually over a period of 3 to 5 weeks before mating and producing eggs that exit the human body in feces. If deposited on soil with the proper nutritional support, moisture, and warmth, larvae hatch, feed on bacteria and organic matter, and migrate to the soil. In their life in the mud, larvae transform twice, eventually into a form which can live in the soil for up to 2 years, ready to infect the next human body with which they come into contact. Now, in the bodies of Egyptian agricultural laborers, the temporality of a hookworm infection was more complex than the sum of the days of a single infection's progression. Experiences of hookworm, consequently, could stretch much longer than the 1 to 3 year lifespan of the organism, as dormant larvae stored in muscle tissue in the human body could replace dead worms and also allow the infection to perpetuate itself. The temporalities of hookworm infection also overlapped with those of other diseases inside the body, and specifically those of schistosomiasis and pellagra. Now, the relations that bound human bodies to the ecologies of the perennial Nile were significant in the production of historical subjectivity. The trick to figuring bodies conceptually is reconciling their consistency, so the composite nature of human bodies in any historical moment is remarkably similar, reconciling this with the porousness that marks them as spatially and temporally specific entities. Within the geographies of the perennial Nile, normative experiences of the body included the symptoms of disease. The subjects who lived in regions with access to perennial irrigation were molded through social categories that included questions of gender, class, and religious affiliation. These same subjects were also shaped by encounters with disease and the presence of physical pain in their daily lives. So it is a tricky business trying to figure out how to read pain from the archive, but the certainty of its presence demands that we grapple with pain and disease as a historical force. Now, the next piece that I'd like to turn to concerns the significance of environmental disease in shaping the practice of medicine in Egypt. So that these diseases became so common as to be normative in the territories of the perennial Nile River had important implications for the imaginaries that undergirded the practice of medicine in Egypt. This was especially the case for those diseases that were caused by parasites. the Ottoman Egyptian state had established a medical school and a hospital at Qasr al-Aini in Cairo. This state had also established a network of hospitals in the 19th century. Now, during the British occupation, which began in 1882, European physicians assumed control of these institutions. Now, interestingly enough, the colonization of Egyptian medicine coincided with the expansion of the geographies of the perennial Nile, especially after the completion of the 1902 dam. Many patients at Egypt's main hospital and medical school at Qasr al-Aini hailed from regions whose agricultural ecologies had been transformed through the introduction of perennial irrigation. And while the multi-species ecologies of irrigation remade Egyptian bodies, the institutionalization of medicine in Egypt aided in the discovery of these same bodies by European scientists. Now, the research performed by physicians during the occupation helped to disentangle parasitic disease from the environmental changes that marked the coalescence of colonial economy in Egypt. Decades before the start of the occupation, the young German scientist Theodor Bilharz had identified the worms of schistosoma parasites in autopsies of Egyptian patients. So he found these worms in the bladders and recta of autopsy patients during the 1950s. Now, Theodor Bilharz lends the disease one of its names, bilharzia. Now, Bilharz considered parasites one of the defining marks of Egyptian bodies. And in his letters home, he oftentimes speaks of Egyptian bodies as made particular by the overwhelming presence of parasites within them. Now, the physicians who dominated Egypt's medical institutions during the colonial period made a very similar kind of move, which meant that although these parasites were acquired rather than inherited, endemic parasitic disease became one way through which race in Egypt was made physical and particular to the country. Now, in 1910, Mark Ruffer, who was the president of the Sanitary, Maritime, and Quarantine Council of Egypt, identified the eggs of the schistosoma hematobium parasite in the kidneys of two mummies from the 12th dynasty, so roughly 1250 to 1000 BC. Now, Ruffer's discovery demonstrated that schistosomiasis had afflicted Egyptians for thousands of years. And in the period that followed this discovery, colonial physicians almost never referenced schistosomiasis without also mentioning its ancient roots. Now, the description of the disease as ancient works to elide the significance of colonial economy and its attendant environmental transformations in altering the bodies of those who populated the perennial Nile. Ruffer's discovery enabled the portrayal of schistosomiasis not only as endemic, it rendered this endemicity ahistorical, flattening the recent history of the disease and its relationship to the ecological practices that facilitated colonial economy. Now, one of the observations that I want to make is this reference to schistosomiasis as having been in Egypt since ancient times, relatively unchanged, persists in the contemporary literature that is produced by global public health organizations. Now, during the interwar period, the notion that schistosomiasis was a particularly Egyptian disease helped to shape public health priorities. When a quasi-independent regime took control of Egypt after World War I, treating parasitic disease became a national priority. A change in Egypt's political status also meant the rise of Egyptian physicians and scientists to positions of prominence within the medical school and also within the public health department. So in November of 1922, Egyptian parasitologist Muhammad Khalil was appointed to lead a new section of the public health department, which was called the Bilharzia Research Section. Now, Khalil was one of the most famous of the physicians and scientists of the period. With Khalil at its helm, the scientists who were associated with the Bilharzia Research Section administered field studies, they sponsored research, and they also oversaw treatment programs related to a set of endemic diseases, and primary among those diseases were schistosomiasis, hookworm, and pellagra. Now, research on endemic disease created opportunities for Egyptian physicians to showcase their expertise and also their positional advantage. So in their access to rural communities, Egyptian physicians had a leg up on their European and their American peers, which was no small matter in the wake of a colonial order that sought to contain and sideline Egyptian scientific and medical expertise. Now, beginning in 1920, clinics devoted to the treatment of hookworm and schistosomiasis in particular were established in Egypt's major towns and cities, and also at different sites in the countryside, especially in the Nile Delta, where the prevalence of schistosomiasis infection was highest. Private physicians also treated parasitic disease. A physician named Ramses Girgis, who worked in the town of Tanta in the Nile Delta, was among the most prominent of these physicians. So in the short years after treatment began, it became clear that hookworm was relatively easier to eliminate than schistosomiasis. And by 1927, the treatment regimen for hookworm had been reduced to a single dose. That for schistosomiasis was lengthy and painful and consisted of a month-long series of injections, the side effects of which were considerable. Now, in addition to the physical discomfort that came with treatment, a month without wages was a difficult proposition for most rural Egyptians. The numbers of patients attending clinics tended to decrease during the times of the year when the demand for agricultural labor was high. Despite these difficulties, by the middle of the 1940s, approximately 400,000 patients passed through treatment facilities for parasitic disease each year. Now, one of the primary problems with the treatment endeavor was the threat of reinfection. Most patients, even if cured, became sick again through labor patterns and also modes of daily life that were during this period inescapable. Recognizing this challenge, physicians and scientists sought other means of reducing the prevalence of disease. In 1927, the Rockefeller Foundation was invited to Egypt to begin a large field experiment looking to test the effect of hygiene measures on rates of parasitic infection. The two lead parasitologists on this project were Claude Barlow and James Allen Scott. And Barlow and Scott conducted a 7-year experiment in which they measured the effect of constructing latrines on the prevalence of parasitic disease. So the notion being that because hookworm and schistosomiasis were passed through urine and feces, the construction of latrines could reduce rates of infection. So during this period, obviously, the vast majority of Egyptian villages lacked latrines, and their residents defecated in the open, their feces one piece in the pathway of disease transmission. Now, when this experiment had come to a close and its results had been assessed, Barlow and Scott concluded that while latrines had made for more pleasant villages, they had failed to reduce the rates of parasitic infection. Assumptions about hygiene, and these are particularly colonial assumptions about hygiene, had overwhelmed what scientists working in Egypt had recognized since the first decade of the 20th century. And that was that rates of infection with hookworm and schistosomiasis were highest among laborers who toiled in fields and irrigation canals, and who had very little opportunity to use village latrines. While shoes might be worn to prevent the transmission of hookworm, the experience of schistosomiasis was that of agricultural labor itself. Now, another environmental strategy to reduce rates of schistosomiasis infection targeted the snails that lived in networks of irrigation canals and drains. This approach was rooted in the proposition that if the intermediate hosts for schistosoma parasites were eliminated, parasites would not be able to undergo the organismal changes that allowed them to infect human beings. So experiments to eliminate snails using chemical agents began in the 1920s, and in the 1940s, the Egyptian government formed a new section within the Public Health Ministry, which was called the Bilharzia Snail Destruction Section. This section of the ministry attempted a combination of techniques to try to eliminate snails from canals. The methods that were deployed included the application of chemical agents to canals, the implementation of a mandatory period of closure during winter, and also designed by Claude Barlow of the Rockefeller Foundation, the use of a special wire net to clear waterways of mollusks and the vegetation in which they lived. Now, as I just mentioned, Claude Barlow left the Rockefeller Foundation and during the 1940s served as the quote unquote expert who was appointed to the new section. Barlow was especially keen on the use of the net to remove snails, as he believed that the strategies of canal closure and the application of chemical molluscicides were ineffective. Now, despite these efforts, throughout the interwar period, rates of schistosomiasis remained stubbornly high. Now, I want to close today by sort of looking at what happens in the second half of the 20th century and providing you some window onto that. Now, in the second half of the century, under the post-colonial regime that emerged after the 1952 Free Officers' coup, and especially during the presidency of Gamal Abdel Nasser, the approach to schistosomiasis treatment in Egypt persisted much as it had during an earlier period. So throughout the second half of the 20th century, millions of Egyptians continued to receive injections that were meant to eliminate the disease from their bodies. Efforts to rid the environment of the parasite's intermediate snail hosts expanded as global public health organizations and foreign governments became involved, both of these parties promoting the application of many thousands of tons of chemicals to the canals that watered Egyptian agriculture. Now, even in the second half of the 20th century, these efforts continued to fail, and those who were treated often became reinfected through environmental contact. Where it concerned the chemical treatment of the environment, this form of approach proved both too costly and also too toxic. Schistosomiasis only ceased to be a national crisis after the development of an oral treatment for the disease, which was distributed widely in Egypt beginning in the 1980s. Now, in the midst of our ongoing historical crisis, that of the COVID-19 pandemic, I have spent a long time reflecting on the definition and conditions that frame epidemics of disease. Schistosomiasis, for example, is generally not talked about with the language of epidemic because its transmission is rooted in environmental contact. So in other words, it is not communicable in the strict sense of the word. And yet there are some striking similarities between our current moment and also the history that I write about in Egypt. In both contexts, environmental change, a kind of human environmental greed, helped to produce the conditions of outbreak. Similarly, labor has played and continues to play a primary role in determining both who became ill with schistosomiasis and who is becoming ill with COVID-19. There's often a story behind human disease that involves a broader non-human material world, one that can be obscured by notions of communicability that omit the environment. So with these thoughts, I'd like to thank you for your time today and also your patience with our technical difficulties, and stop and open the floor to questions and discussion.
Thank you very much, Jennifer. That was a very interesting and insightful talk. A reminder that if you would like to ask a question or leave a comment, please enter it in the chat box, and I can relay it. I will start. So I have two questions that I guess aren't particularly related. So maybe I'll ask the one, and then if I have an opportunity, I'll come back to the second. You talked about the way in which schistosomiasis helped to racialize Egyptians from the colonial point of view. I wondered about whether or not that persisted following independence, and if schistosomiasis is seen as a marker of Egyptianness, if there's such a thing, after 1952, and how that functions if it's not the colonizers who are identifying schistosomiasis as an Egyptian trait. Does it function differently if it's the Egyptians themselves who are identifying it as an Egyptian trait? So.
Thank you so much for that question, Carl. There are about 5 questions in there, and so I'm going to attempt to answer them in brief. So the first sort of answer that I want to give has to do with the ways in which I think about the production of race within medicine in the early 20th century, right? And so one of the arguments that I make about schistosomiasis in my book is that, tropical medicine, and specifically autopsies. So autopsies were very, very common in the practice of colonial medicine. And it was common that European doctors saw and observed patients more often dead than they did alive, right? So, which had particular implications in the sense that European doctors tended to describe bodies as dead bodies rather than bodies in motion or particular kinds of behavioral patterns. So one of the things that we see in Egypt, which we also see throughout the colonial world, is that European doctors looked for particular physical traits as a means of producing notions of biological race, right? So much of that conversation in the scholarly literature has focused on how European doctors talked about and wrote about race as physiological. But one of the things that I see in my work, and that we see in other tropical medical contexts, is that another way in which race was produced is that colonial populations were thought to be closer to the environment and closer to nature than European populations. And so the presence of dirt, the presence of parasites, the presence of other forms of disease that were thought to be environmental diseases came to sort of mark the race of these populations as distinct in the minds of colonial physicians and within these medical establishments. Now, the question that you asked about sort of the post-colonial period or after 1952, I think is a really good one. So the first observation that I will make is that certainly it is also true that within the literature of science and public health that is produced by Egyptian physicians and scientists, Egyptians also sort of mimic this language of talking about schistosomiasis as ancient and as coming from the time of the pharaohs. So that's a discourse that is not just particular to global public health or to colonial medicine, but also persists in the way that many Egyptian experts talk about the disease. And that's an argument that's both right and wrong, in the sense that schistosomiasis is endemic in Egypt, meaning that it existed in Egypt before the construction of Khazen S1 and the transformation of Egypt's irrigation landscape, but also the kind of symptoms that we see from schistosomiasis, the rates of infection, and also the territories that were occupied by the different parasites that cause the disease, all of these shift dramatically with the construction of dams and the introduction of perennial irrigation. I think I would say that in the post-1952 period, I think race does continue to be important, but I would sort of move analysis of that category from the actual processes of medical examination to thinking about treatment regimens. So, I'm currently working on a book about liver disease in the second half of the 20th century in Egypt, which is in part connected to the history of schistosomiasis. And one of the things that I have observed is that, beginning in the 1950s, the favored response of global public health organizations like the World Health Organization was to use massive quantities of chemicals to dump on the Egyptian agricultural environment in an attempt to kill snails. Many of these chemicals had been not properly tested. In fact, sites in the global south, like Egypt, were precisely their testing ground. And the World Health Organization worked very closely with foreign governments and foreign chemical and pharmaceutical companies in these kinds of large field experiments. So I would argue that in this context, one of the functions of race is that in the post-colonial period, places like Egypt become a kind of large field experiment for public health organizations and also chemical companies in ways that are hard to imagine happening in the United States and Europe. So I think that race continues to be important, but its kind of significance and the way it's deployed shifts with the politics of the moment.
Great, thank you. A question is, I wonder if the centuries of broad and chronic exposure to these diseases was also seen in city dwellers. And I would speculate that the lack of categorizing this not as an epidemic might be due to prevalence among the lower class of workers.
Well, to begin with the second part of the question, that is certainly correct. Okay, so obviously, because of its relationship to kind of daily forms of environmental contact that involved irrigation canals and drains, and also agricultural labor, schistosomiasis, hookworm, and pellagra were all concentrated among the kind of laboring classes in rural areas. That said, it was also fairly common for city dwellers to develop, especially schistosomiasis. So, one of the things that's important to observe is that the boundaries between rural areas and urban areas were somewhat porous. So, especially as large cities like Cairo and Alexandria expanded, they came to encompass villages that had irrigation canals in them. Okay, so in the 1950s and the 1960s, one of the sort of primary public health issues has to do with schistosomiasis infection among populations of urban industrial workers. Okay, now in part, this happens because as cities expand, they contain irrigation canals. They don't always have access to the infrastructure that would have provided running water. And so these boundaries between city and agricultural space are not definite. Among upper class populations, however, the disease was certainly less common among upper class populations, but people certainly became infected. So upper class populations often had kind of, estates in rural areas that were known as esbas. People would visit these estates. When children were young, they would often play in kind of irrigation canals during the summertime to cool off. And so there was some prevalence of schistosomiasis among urban and upper class populations, but not to the same extent. Right. So one of the kind of famous stories of Egyptian history was that Abdul Halim Hafiz dies of liver failure. Okay. So many people know this, and it's debated historically whether he dies of liver failure that's caused by hepatitis C or liver failure that's caused by schistosomiasis. And indeed, he dies of liver failure that's caused by schistosomiasis. So the disease has certainly a place in the national imagination. It's not only the lower classes who are infected, but it is disproportionately rural populations and lower class populations who suffer from the disease.
Your comment of wide use of chemicals to rid canals of snails without complete knowledge of side effects is reminiscent of many instances in the US where lower economic groups are subjected to water quality problems. Most recently, lead in water, but more commonly chemicals from processing plants, military bases, enter the water table.
Yes, yes. So I think, um, one of the sort of contemporary issues that is certainly discussed quite often in Egyptian medicine has to do with the prevalence of both kidney disease and liver disease. And there's a great book by Shireen Hamdi, a medical anthropologist of Egypt, who wrote a book about organ transplants in Egypt, specifically kidney transplants, called Our Bodies Belong to God. And one of the issues that Shireen raises in her work, and it comes up also in my work, is that environmental pollution is widespread, both in cities and in the countryside. And that pollution has multiple causes. Some of it is from the prevalent use of agricultural pesticides. Some of it is certainly from these chemicals that were used in the attempt to kill snails. Other, especially rural pollution, has to do with as cities and towns expand quite rapidly, especially in the 1950s and the 1960s. So if you want to, an example of this would be, the central Egyptian, once towns, then cities of Minya and Asyut, who underwent these processes of just tremendous growth. And as this happens, and as industry becomes more prevalent, one of the effects of that is also the spread of industrial pollution into the countryside. And so I think, I think there are commonalities with some of the issues of environmental toxicity that we see in the US. But I also think that there is something particular to the global South about the story of global public health and global pharma using large quantities of chemicals on these sites in the global South as means of kind of testing treatment endeavors for disease.
So going back to the period before the first dam was built, and this is sort of a question about how to think about major infrastructure generally.
Yeah.
What kind of foresight was there? So a couple of things occur to me. One is, if you're going to stop the flooding of the Nile annually, you're not going to get the silting. That would seem like that would be something you could think ahead and guess might happen. Schistosomiasis spreading to the population, that would be harder to predict. So one would be the sort of negative consequences. What could you imagine would be the negative consequences of doing something like damming the Nile? On the other, you could sell the idea with the positive consequences. So we're going to build this now. We're going to be able to control irrigation, and if we control irrigation, then we can have the following cash crops: cotton, for example. So my question is about the foresight. What was imagined was going to happen, both positively and negatively, but when the planning for the dam was happening.
That's a great question. So, one of the things that I will say is that it's really important to think about when the 1902 Aswan Dam was constructed within a broader kind of global field of civil engineering. Okay. And so, one of the remarks that I'll make, so Khazen Aswan is constructed under the British. During the British occupation of Egypt, British officials were incredibly concerned with increasing the production of cotton, both because most of that cotton flowed to textile mills in the north of England, so this kind of classic colonial economic relationship, but also because, the pretense for the British occupation of Egypt was that the Ottoman Egyptian state was in deep debt. And British officials argued that the production of cotton and perennial agriculture more broadly was the way by which the Egyptian state would walk itself out of debt. And that had a lot to do with taxes on agricultural land. In thinking about how British and Egyptian engineers at the turn of the 19th century imagined what would happen with the construction of a dam and what the kind of side effects would be, that's a complicated question. The first observation that I'll make was that their primary concern was one of agricultural productivity and cash crop production, right? I argue that it's important to think about the global histories of civil engineering because this was a period in which, while more and more dams were being built, there were not many dams that had been in existence for large numbers of years, through which one could study the environmental effects of dam construction, right? So the kind of last years of the 19th century, this is when globally this process of dam construction really starts to pick up. It was also a relatively haphazard affair. So an interesting sort of development in Egypt is, after they finish the dam, it starts to erode and destroy itself rather quickly. So just 3 years after they finish the dam, British engineers begin a project both to heighten the dam so that there's more water in it, but also to repair the dam because they hadn't anticipated particular problems with its construction. And so I raise this issue to highlight that there was not a tremendous knowledge as to the kind of complex environmental interactions that produced fertility in the soil, right? This is the period of modernism, which meant that, the discovery of artificial nitrate fertilizers, people had a lot of faith that it didn't matter if you altered the environment. It was very, very possible to just fix those with the production of artificial fertilizers. And so certainly by, kind of 1910, there's a lot of discussion in Egypt about the deleterious effects of constructing the dam. Many of those effects were not anticipated in the lead up to its construction. I also want to say that as it pertained to schistosomiasis infection, it was not until the period of the First World War that scientists understood all of the pieces in the chain of schistosomiasis transmission. So doctors certainly had a sense in the early 20th century that agricultural laborers were more likely to get sick with the disease, but they didn't yet understand the precise mechanisms by which that occurred.
Great, thank you. In America, we see young people becoming voices that can't be ignored, addressing climate change and environmental toxicity issues. Do you see this change of youth being empowered in Egypt?
I think that's a great question. I mean, the first thing that I would say is, absolutely, almost 10 years ago, Egypt had a revolution that in many ways was powered by young people and the voices of the disenfranchised. So there are many things that I could say about the fate of that revolution in contemporary Egypt. But I would say that, young Egyptians have proved to have strong voices on a range of issues. Those issues certainly concern environmental issues and also, the medical effects that stem from those environmental issues. I think the issue is complicated right now in contemporary Egypt because for the past really decade, the conversation about water in Egypt has been dominated by the debate and the fears that accompany the construction of the Grand Renaissance Dam in Ethiopia. And so, one of the dynamics that we see emerge in Egypt in the 1920s that continues to the present day is that water, and specifically access to the Nile, is considered a nationalist issue, right? And so there is, a large conversation both within the Egyptian government right now, but also among water engineers about what Egyptian agriculture and specifically questions of sustainability should look like moving forward and how to produce a more sustainable agriculture in Egypt. However, access to the Nile is also historically regarded as the kind of historical right of the Egyptian people. And so, I would say, it's a long answer to your question, but I would say, yes, there has certainly been environmental activism among the youth, but elements of that environmental activism are made more complicated by the significance of the Nile and access to its waters within nationalist discourse.
Are these disease issues you describe also seen with similar prevalence in other countries upstream, the Sudan, Ethiopia?
Yeah, so yes and no. So in short answer, yes. And I would say that this is particularly relevant today. And I say that because the world is experiencing in our contemporary moment the sort of largest wave of the construction of large dams ever historically. Okay, so dams are being constructed in many places at, I want to say an alarming, but I'll say an increasing rate. And that said, in many places, but especially in regions in which schistosomiasis is endemic, we see exactly the relationship between first a dam and then an increase in schistosomiasis infection that we have seen in Egypt. Some of that depends on what is endemic to the environment itself. So parasites move along water systems, but water systems don't look the same. That said, there certainly has been a problem with schistosomiasis in Sudan, and it has been a matter of debate, as well as in other places on the African continent, in which large dam construction has produced these outbreaks of disease. Now, one of the things that's particular is that, the prevalence of disease is in part determined by casual contact with water. It's also determined by specific practices of agriculture and labor regimes. So how we see disease and which populations we see disease sort of emerge within, those are sometimes questions that are particular to place.
Well, we can't let you go without asking about your thoughts about the Grand Renaissance Dam. So, my earlier question, can we think about consequences? Most people, when they think about the GERD these days, are wondering about consequences that have to do with political interactions between the countries involved.
Yeah.
Do you have an opinion about environmental effects of GERD on downstream or in Ethiopia, or is that too far in the future to be able to comprehend?
No, I don't think. I think it's a really important question. So it's interesting when I wrote a book that included a dam. People often ask me this question. They're like, are dams good or bad? Should we build dams? Should we not build dams? Dams, obviously, you're arguing they cause disease. That seems bad. And I think my argument would be a little bit different. And my argument would be that, we as human beings exist in relationships with the broader environment. no matter which world we live in. Changing pieces of that environment also change our relationships with those environment, right? So I think, I would see dams not necessarily as particularly bad, but as one potential agent of environmental change. That said, I would also argue that in many places in which dams are being built, especially large dams, while the reasons for those dams are good ones, and those reasons usually have to do with the production of hydroelectric power and also a promotion of agriculture, what oftentimes doesn't come into kind of the cost benefit formulations associated with large dam constructions are, the tremendous public health costs that will emerge as a result of their construction. I think one of the issues that we see with the construction of the dam in Ethiopia is particular to the Nile, and it's also a broader question, and that is the question of sustainable agriculture, right? So it is certainly true that the construction of the dam in Ethiopia is going to make it impossible for Egyptian agriculture to continue as it had in the past. It is also true that climate change is doing that in and of itself, right? So these questions of how we structure agriculture and how agriculture can be sustainable in the long run, given a changing climate, those are very important questions in Egypt. Those are very important questions in California, which similarly does not have a deep history of sustainable agriculture. And so I think, it is true that much of the conversation about GERD has been a kind of conversation about diplomacy and the potential for war. And that does not look good. But I think I would like to raise the broader question of, dam or no dam, we're all living in a world in which we're going to have to rethink the modes that characterize agricultural production and how those modes might be less resource intensive moving forward.
Well, thank you very much, Jennifer Derr. This was a really wonderful and articulate presentation. I know I speak for the audience members as well, that we got a lot out of it, and it was very kind of you to join us here today. If you could, we would applaud. We can do the hand clap there. So thank you very much. And again, everyone for joining us, thank you. And we look forward to seeing you next time at the next Sesame event.
Thank you so much for hosting me.